A very good day to you all. In our last topic, we treated analytical chemistry. That's talking about the different types. We gave a definition, we talked about the types, which is the pre-analytical, the analytical, and the post. So we have dealt very well on that. I'm not going to be wasting much of our time because we have a lot to cover. So I told us we're going to be looking at different analytical instruments. The first one on my list here is colorimeter. Colorimeter. Now, colorimetry is the measurement of colors. It is the measurement of colors and is probably the most widely used method for determining the concentration of biochemical compounds. So generally what we do in colorimetry is measurement of color. So the substance to be checked, by the time you add the sample, you add your reagent, there should be a color change. Okay, we'll look at the principle. Now, when white light passes through a colored solution, some wavelengths are absorbed more than others. You plug your colorimeter, for example, you put your cuvette, your sample is in it, by the time light passes through it. So what we are saying is that when white light passes through a color solution, some wavelengths are absorbed more than others. So let's continue. Now, the extent to which a solution is absorbed, light depends on the intensity of its colors. So some colors are thicker, or should I say denser than others. So the extent to which the solution can absorb light depends on the intensity of the color. 3. Light travels in the form of waves. 4. Wavelength is the distance between two waves. So we have a diagram that comes from the down, goes up, comes down, just like a mountain and a valley. So the peak of it is known as what? The distance between two waves. This is a wave 1, another wave 2. Distance between the two of them is known as wavelength. Then we'll have what we call amplitude. Amplitude is the height of each wave. The height, the peak. Frequency is the number of waves passing at fixed point per time. The number of waves per time. Then we have what we call monochromatic light. When we say monochromatic light, what do we mean? A light that has one color. Mono means one, chromatic means color. A light that has one color. So follow me. Tiny colors that is seen emitted light. It has a particular wavelength, and this is known as monochromator. So we say a light of just one wavelength is what? It's a monochromatic light. Wavelengths between 400 nanometer and 700 nanometer are known as what? Visible. Why that which is then the ultraviolet have less than 400 nanometer. Anything less than 400 nanometer is ultraviolet. Then if it is higher than 700 nanometer, it is known as what? Infrared. So we'll be looking at a word known as absorption of light. What do we mean by absorption of light? Light falling on color solution is either absorbed, reflected, or transmitted. Take note, when a light falls on the cuvette, the light is either absorbed, it is reflected, or transmitted. So we're going to go to the principle of colorimeter. That is where we talk about the Beer-Lambert's law. So we'll just briefly look at what the Beer's law is. The Beer's law, the proportion of the incident light absorbed by the molecules in the solution is directly proportional to the number of absorbed molecules in the substance. The proportion of the incident light absorbed, the proportion of the light absorbed is by the molecules in the solution is directly proportional to the number of absorbing molecules in the. We're looking at the Lambert's law. Lambert's law states that when monochromatic light, when a single light passes through a color solution, the amount of light that is absorbed increases with the increase in the thickness of the layer of the solution through which the light passes through. Then combination of these two are known as the Beer-Lambert's law. The Beer-Lambert's law is the law that most of our equipment, for example, the colorimeter, spectrophotometer, etc., that is the law that they follow. So what is Beer-Lambert's law? We'll look at Beer-Lambert's law. The basic principle of colorimetry, absorptiometry, and spectrophotometry are expressed by combining Beer's law and Lambert's law. Now, this joint law shows that under suitable condition, the amount of light that is absorbed by color solution is what is proportional, is directly proportional to the light part and the concentration of the solution. I go through it again. Beer-Lambert's law shows that under stable conditions, The amount of light absorbed by a color solution when illuminated with a light of suitable wavelength is directly proportional to the concentration of the solution and the light path through which the light path. Therefore, the amount of light decreases exponentially with the increase in the concentration of the solution and with increase of thickness of the layer in which light passes. So some of the terms we use in colorimetry: number one, light paths; two, transmitters. So those are some of the terms. Transmitters. Then Beer-Lambert's law can be applied in clinical chemistry in quantitative analysis. Take note. So I'm going to come in my next lecture to come and talk about spectrophotometry. We'll talk about the principle and some other things. So see you in my next class. Bye.